All right, so here we want to find the derivative of y. So we're looking for dy dx. So before we get started on that, let's look at the four main general derivative rules that we have been discussing. So we have number 1, the power rule. Number 2, the product rule. Number 3, the quotient rule. And number 4, the all-powerful chain rule. So it looks like in this problem, 3 of these rules apply. So we have an exponent here. So we're going to use the power rule. We have an expression that's a fraction in here. So we're definitely going to use the quotient rule. We have the quotient of two expressions with x. And we have an overall expression that could be written as the composition of two functions. So we have this inner function, which is the fraction, and the outer function, which is the negative 2 power. So we're going to use the chain rule. Product rule in this one is left out. Bye-bye, product rule. Okay, so let's see if we can apply these 3 derivative rules. All right, so dy dx is equal to, well, let's start with the chain rule, because of these 3 rules, the chain rule is the one that applies to the entire problem. All right, so the chain rule says the derivative of the outer function, which is the negative 2 power. So the negative 2 comes out front, drops by 1, inside stays the same, 3x squared minus 2 over 2x plus 3. And then we multiply that by the derivative of the inside function. So the derivative of the inside, which is 3x squared minus 2 over 2x plus 3. So to figure out this part, we need to apply now the quotient rule. Okay, so dy over dx is equal to, so we got a negative 2, 3x squared minus 2, oh, that parenthesis should be bigger, let's rewrite this. Actually, negative 2 times 3x squared minus 2 over 2x plus 3 to the negative third. Now we're going to multiply this. So let's apply the quotient rule. Low d high minus high d low over low low. Or at least that's how I remember it. All right, so the bottom, the denominator, 2x plus 3 times the derivative of the top. So the derivative of 3x squared minus 2 should be 6x. So applying the power rule here, 6x minus, I'm going to actually erase this to give me a little more room. And I'll rewrite this a little bit neater. So 2x plus 3, low d high, minus top, 3x squared minus 2, times the derivative of the bottom, which is 2. Derivative of 2x is 2, and the derivative of 3 is 0. And we will divide this by the denominator squared. So that's 2x plus 3 to the second power. Okay, so let's see what we could do here. So I'm going to take this exponent and split it up between the numerator and the denominator. So we'll say negative 2 times 3x squared minus 2 to the negative third power over 2x squared plus 3 to the negative third power. So I'll just apply that negative third power to both. Okay, rule of exponent allows us to do that. And the reason I'm doing that is because now we have the power of 2x plus 3 on both denominators. 2x plus 3 to the second power. All right, and now let's multiply everything out and see if we could simplify. Okay, so 6x times 2x, that's a 12x squared, and 6x times 3, that's an 18x. Then over here, 2 times 3x squared, so that's a 6x squared, and that's negative. And 2 times a minus 2 is a minus 4, so it's a minus 4, or a plus 4. All right, so now we can combine, if we're multiplying, we can combine those exponents. So, that should be dy over dx is equal to, so it looks like on the bottom we have a 2x plus 3 to the negative 1 power. And we have a minus 2, 3x squared minus 2 to the minus 3 power. So we could actually, you know what, I'm going to bring that down to the bottom. Oh, we'll do that in the next step. Negative 2, 3x squared minus 2 to the negative third power. And let's see, we have 12x squared minus 6x squared. That's 6x squared plus 18x plus 4. All right, so let's shuffle some stuff around here. dy over dx is equal to, well, this negative exponent goes to the top and becomes positive. This negative exponent goes to the bottom and becomes positive. All right, so negative 2, bring the 2x plus 3 up top, times 6x squared plus 18x plus 4. And we'll bring this factor to the bottom. So that's 3x squared minus 2 to the positive 3 power. We could factor out a 2 here, since each of these three terms are even numbers. So if we factor out a 2, that will become a negative 4. 2x plus 3 times 3x squared plus 9x plus 2. And that's all divided by 3x squared minus 2 to the third power. Whew, quite a bit of algebra here. All right, and that is our derivative. And this doesn't look very simple, but this is as simple as it could get. Now, there are many paths through this problem. Many paths through the algebra from the original problem to the derivative. One thing we could have done, we could have taken this original problem, the 3x squared minus 2 over 2x plus 3 to the negative 2 power, and we could have rewritten that as the reciprocal to the positive 2 power. So we could have said So this was the original problem. We took the derivative straight away. Another method we could have used, and this might have been a step or two shorter, I don't know. We could have, before taking the derivative, rewritten this as 2x plus 3 over 3x squared minus 2 to the positive 2 power. We could have done that. And then apply the chain rule. We also could have rewritten it as 2x plus 3 to the second power over 3x squared minus 2 to the second power, and started with the quotient rule. So there's a lot of different ways. So when you see my solution, it is my solution, not the solution or the only solution. There's probably 10 ways we could sort of meander through the algebra to solve this problem. Either way, we would get to the same place, just with a slightly different sequence of steps. Okay, that about does it for this one.